In organic chemistry, we will be using different types of formulae, and the type of the formula required will depend on the information that we are dealing with. For example, we may want to know the way the atoms are arranged within the molecule, or we want only to know the number of each atom present. So there will be different ways of doing this. Let's start with the displayed formula. This type will show every atom and every bond in the molecule. So a single line represents a single bond. A double line will represent a double bond, and a triple line will represent a triple bond. So these are examples of the displayed formula. In the first one, we have one carbon atom bonded singly to four hydrogen atoms. So we have four single bonds. In this one, for example, we have four carbon atoms where these two carbon atoms are bonded to three hydrogen atoms and to one carbon atom as well. So this type of formula will show every atom and every bond. If we take ethene, for example, C2H4, this is the displayed formula. So we have the two carbon atoms where we have a double bond between them, and each carbon atom is bonded singly to two hydrogen atoms. Now we will examine the structural formula. So this formula will show the unique arrangement of atoms in a molecule in a simplified form. So we will not show the bonds. We will show only the atoms in a molecule. So for example, if we want to write the structural formula of this molecule, we have one carbon atom and we have four hydrogen atoms bonded to it. So we will write CH4. If we want to write the structural formula of this molecule, we will start with the first carbon atom. So it is bonded first to three hydrogen atoms, so we have CH3, and it is bonded to another carbon atom, so we will write C, and then we will add the hydrogen atoms which are bonded to the second carbon atom, and they are three, so we have CH3, CH3. We will do the same for all those, so we will have CH3, CH2, CH3, CH3, CH2, CH2, CH3, and so on. So if we have branches, we will write this one as CH3, CH, and this CH is bonded to another CH3, and then we have another CH3 group. So we will include them in brackets. This branch will be included in brackets. Let's examine now the skeletal formula. With more complex molecules, displayed structural formula become time-consuming to draw. In a skeletal notation, the carbon atoms will not be drawn at all. So instead of showing the carbon atoms, we will use straight lines which represent carbon-carbon bonds, and carbon atoms will be assumed to be where the bonds meet. In addition to that, the bonds between carbon and hydrogen will not be shown. So if we take this skeletal formula, every line of these represents a bond. So we have here one carbon atom which is bonded to another carbon atom over here, and here we have a third carbon atom, here we have a fourth one, and here is the fifth carbon atom. So the total number of carbon atoms here will be equal to 5. So every bond of these represent two carbon atoms. So we have 1, 2, 3, 4, and 5. And of course, each carbon atom of these can have 4 bonds in total. So when we don't show any atoms here, this means that they are hydrogen atoms. So we have CH3, CH2, 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 and CH3. This is cyclohexane. So we have here one carbon atom, the second one, the third one, the fourth, carbon number 5, and carbon number 6. So we have 6 carbon atoms which are bonded together. In this molecule, we have 2 carbon atoms over here, and each one of them is bonded to a bromine atom. So this carbon atom is bonded to one bromine atom, and this one is bonded also to one bromine atom, and each carbon atom of them will be bonded also to 2 hydrogen atoms. So let's, for example, try to write the structural formula of this. It will be CH2Br, CH2Br.